everyone, and thank you for coming here for yet another installment of the Silicon Valley DevOps Meetup. My name is Mahesh Kumar. I organize these meetups on a regular cadence. Of course, it's sponsored by VMware Code, so really thankful to our sponsors who make this possible, both in terms of the real estate, the cafe, the setting, the beer and the pizza, and all of that good stuff. Today we are trying something unique, actually. We have two speakers, so it's actually a double header. So save your appetite, save your brain cells. We're going to hang tight. It's two really good power-packed topics that we have. But before we get into the speakers and their talks tonight, a couple of housekeeping items. There is a sign-up sheet that's somewhere here. There should be a few of them on different tables. So please enter your name. That's just for us to go back and show that folks actually came here, attended the talks, and get reimbursed for the beers and pizzas, right? It keeps the good stuff going, so paying forward, right, for the next meetup. So please do that. The second thing is I would like to call on Kripa, who spearheads the VMware Code piece within VMware, to help us shine some light on what they do, the kind of activities they are involved in, and how you can also engage with VMware Code. Kripa?
Thank you. Hi, everyone. Thank you for coming. My name is Kripa, and I manage the code program here at VMware. For you guys that don't know what it is, it's our free developer community. By signing up, you get access to our code samples, API, software development kits. We run hackathons, different meetups on campus, and a bunch of events. It's completely free to join, and the program pays for the beer and pizza. So if you like beer and pizza, join my program. It's really easy. Just in the sign-up sheet, just put a little check mark on the very right-hand corner of the sheet. But I really want to say, please, please, please sign up on the sheets. They're spread out kind of everywhere on the tables. That's how I do expense reports. So that's how I get the money to buy the food and the pizza and reserve the rooms for meetups. It's super important to me. Please do it. And then take all the extra food and pizza. No, there's one right behind you. There must, actually, this is a sign-up sheet. Oh, no, it's not. Yeah, they're over there. There's a bunch on the tables. So thank you for coming. I know it's a Tuesday night. I hope you guys have a great night.
Thank you, Kripa. So like I said, we are trying something unique today. We have two speakers tonight. Our first speaker is Clement Pang. He is a founding architect and founder at Wavefront Technologies. Wavefront's a company that VMware acquired about a year and a half ago. They have done a lot of work in terms of metrics, ingestion, and correlation. So roughly throughout their history, you're talking about 70 trillion metrics that have been ingested, and this is without rolling up any historical data, right? And even with that kind of data ingestion there, you're still talking about sub 50 millisecond query latencies. So phenomenal performance. They've learned a lot, not just while building the product and using the service, but also obviously with their customers. Like we say, eating your dog food or drinking your own champagne. So here with us tonight is Clement to share a lot of the learnings from building that platform and then using it on unsuspecting users, including themselves. So with that, Clement. And oh, by the way, there's one fun fact about Clement. He's got perfect pitch, so you can test him on that too at some point, maybe.
Thank you. Hello, everyone. Hi. My name, as I said, as Mahesh was saying, I'm Clement. I'm one of the co-founders and chief architect at Wavefront. And so, very quick introduction, just to say hello. So we are a company. Let me make sure I'm on the camera. So we are a company that VMware acquired last year, and we were founded in 2013. And we are a SaaS company that handles operational analytics. We are cloud first. It's, as I said, a SaaS service. And just a very quick show of hands, who has heard of Wavefront here? Wow, OK. Either you all work at VMware or we are successfully doing a marketing campaign. So who has tried Wavefront? Like you're using Wavefront for some, OK. So part of my job here is not to sell Wavefront. I think that was not the goal. But as part of explaining the journey of building Wavefront. Hopefully you get some ideas on why Wavefront might be a solution that you should look into when you're building modern applications, especially at scale applications. So just a very quick, I think I kind of introduced myself. I'm very active on Twitter, and recently I started blogging quite a bit on Medium. And so a lot of the ideas that I think from operating Wavefront came from just us facing issues, facing scaling challenges, facing outages, facing customer issues, and a lot of that is difficult to capture. And I think very recently I started having the time to just sit down and distill those thoughts. And just so happens that Mahesh was asking me to come talk about them, and so I thought it would be a good place to kind of crystallize those learnings and talk about it. So I think, first of all, I think you may wonder, like, why do you want to hear from a founder? I want to stress I'm a nerd at heart. I code a lot. And so whether it's on a plane, at work, balancing between all the meetings and customer visits and everything. And so my colleagues recently told me there's more than 6,000 commits, a whole bunch of patents that are filed. So it's a substantial piece of code that Wavefront has accumulated. The entire team has accumulated over the years. And so I'm very much attached to coding. I really like to figure out solutions to hard problems, figure out how to make the product sing and how to make our customers experience it better. And so just a very quick introduction. I think we're a metrics company. So if you're using something like Graphite, InfluxDB, Prometheus, or using an open source, commercial piece of software, you probably have touched metrics once or twice in your life. And so we started with this premise that metrics is going to be how we understand machines, software, and even user behavior for the modern application. And so we started that journey, as I said, in 2013. And I always said, if you told me back then that we'd be able to get some of these amazing customers that we'd be able to engage along the way, I would not believe you, right? So some of these customers on the list here, and certainly VMware, after acquiring us, I see some of faces here that they started also using Wavefront to monitor their applications, whether it is on-premise SDDC, shipping kind of health telemetry back to the cloud, as well as our own SaaS services, our own offerings in the cloud. And so Wavefront is just a tool that helps you to ingest all of that metrics into a place where you can visualize, you can alert, you can crunch the numbers, right? So I always said, why do people actually use Wavefront? Now, obviously, you use Wavefront because you want to understand your system, you want to understand what's going wrong, you want to understand, if there's an outage, very quickly you want to isolate to the problem, right? So that's reducing mean time to resolution, essentially. But ultimately, I think the reason why customers are with us today, we didn't, after we got acquired, we didn't lose a single customers, and they're actually even getting bigger and bigger because they're sending more and more data into Wavefront. And the reason for that is we're enabling them to move faster. So to the extent that you could observe how your applications are behaving, how your environment is behaving, you are more confident to push code faster, to make changes to the platform and see that feedback faster. So ultimately, I think a metrics platform enables you to iterate your product, iterate your idea faster than your competition, right? That's all, perhaps is all that matters in the Valley. And so what we're doing ourselves is the same, right? We're using Wavefront to look at Wavefront so that we could be better, so we could push code faster, so you could validate a patch release faster to know that it's doing the right things, and we understand our user behavior faster, so we know where we should be spending time optimizing and whatnot. Yes?
Do you use anything else besides Wavefront?
So we do have, so Wavefront, in terms of observability, there are many, I'd say, pillars of observability. So metrics, we're using Wavefront today.
Can you repeat the question, please?
Sorry, yes. I was told that I need to do that, so thank you for reminding me. So the question is, do we use any other software on our observability journey? And so one of the pillars of observability, as I said, is metrics, and so that's time series data that you're gathering from your application, from your infrastructure, from your cloud fabric, and also just from custom metrics, how users logging in, users seeing errors, all that kind of stuff, right? We also use logging, so that's something that we have to catch things that are not structured time series data. So a lot of times there are exceptions that pop up in Java. Those are not time series. So we need to have some way to gather them. And we do use, well, observability could be very broad, right? So it includes things like security, monitoring with agents on the machine, gathering all the connectivity information and analyzing that to make sure that we're not in breach. Yeah. Cool. So we're using Wavefront essentially for all of our own monitoring needs. Yeah.
So when you say agents?
So we're using Telegraph. Yeah, so I actually have a slide on that. So Telegraph, I would say that's how you get infrastructure metrics. And that's interesting for sure. All of our customers are doing that. But by and large, our customers are monitoring things like, for example, I could use the case of Workday, let's say, right? So Workday, the monitoring infrastructure is interesting in the sense that we know when CPU is pegged, when there's no RAM, when there's out of memory, or your disk is saturated. Those are all interesting things that you want to know about your platform. But if you push a new release, you want to know how many people are engaged with that feature, how many errors are actually popping up from your code change, for example. And given, for example, your weekly usage patterns, did something change? Because let's say you deployed a new SSL cert, right, into your front end, and you suddenly just see, traffic drop by 20%. Maybe like just a couple of browsers, is not happy. And so things like that, Wavefront allows you to gather that data. It could be from Telegraph. It could be from custom metrics. It could be from logs even. So there is a capability in Wavefront to convert logs into metrics. So all of that is just gathered and plopped into Wavefront. And some of our largest customers, they sent almost 1 million data points per second into the system. And so as Mahesh was saying, I think over the lifetime of Wavefront, we've gathered around 70 trillion and counting data points. And one of the unique advantages of Wavefront is that it keeps the data at the original resolution. So a lot of systems, they just roll up the data to per minute or per hour. And you basically can't look at last year with the same resolution that you get today.
You keep it for 1 year?
We keep it for, on contract, it is 18 months. Yeah, so that's how much we have. And so this is, again, not a talk about selling you Wavefront. So I really want to talk about how did all of that happen, right? So if any entrepreneur tells you, like, you figured out the roadmap, right? You knew that's 200 features that you have to build on day one. That's a lie, right? We all started companies because, we had an idea, we had a vision of how operation analytics is going to happen. And we basically, figured out all the requirements kind of along the way, a lot of times because we hit roadblocks, right? Because we ran into a situation that we didn't expect, for example, the cloud provider to have, and we just have to iterate and innovate around those problems. And a lot of times, talking to customers, understanding how they're using the platform, how they're running into issues, for example, and how we ourselves are running into issues with our own platform, that help drive us improve the products. And I think that's a very important part of what I tell entrepreneurs a lot is you have to be able to use the product. I know there are industries out there, for example, that I guess I have a lot of that I think that they're just doing very well because, like SpaceX, for example, like if you're shooting rockets into space, you just have no idea how you are using the product, right? It's just basically, they're iterating in a vacuum and understanding simulations and then shooting it up and be like, wow, kudos to them, it works, right? But for us and for many applications or companies out there, you can actually use the application to understand, what are the gaps and how do you actually innovate, right? So it happens to us that Wavefront is a SaaS product. It is a monitoring product, right? And so we have to monitor the platform itself, right? So we used Wavefront heavily. And oftentimes we ask the same question, perhaps like you asked, where, how do we monitor Wavefront? How can we make sure that Wavefront itself can gather as much data as possible? So I recall very early on, we were just like a time series platform. It was just taking in data. And I remember we had a script that we need to scrape AWS metrics, right? So in the past, AWS, still today actually, AWS is CloudWatch, and you could get the metrics from CloudWatch. And for a long time, we were like, okay, we don't kind of like the interface in CloudWatch. We need the metrics in Wavefront. So we wrote a script, and then we would just get metrics from from CloudWatch and ship it to Wavefront. And then after a while, we realized like most of our customers want it, right? And most of our customers actually want their CloudWatch data in the product itself. So what we started doing is to ship the script to them, right? We tell them, like, this is the script we use. You could run it, and then you customize all the stuff. And after a while, people are like, well, we don't really want to run the script. We just really want to give you some credentials that allows you access to the CloudWatch platform, and you get the metrics for us. And what we've learned then is how do you scrape the metrics most efficiently on behalf of our customers, right? And plopping it into Wavefront. So a lot of these requirements just come out of us needing something, and then we're realizing our customers needing that thing, and then productionizing it. And after productionizing it, making many tweaks to make sure that it's behaving optimally. You probably know CloudWatch charges money when you actually query the metric from AWS. So you want to do it as efficiently as possible, right? So I think we spend a lot of time making sure that we make the least number of queries to get the metrics, right? So that's just one aspect of us building the platform. So I want to talk about a couple of dimensions, and I think this slide probably will help you understand how we actually get data into Wavefront. So we do have the Wavefront proxy, which is a piece of software that you install inside your infrastructure. And you can have agents that are talking to the proxy. So that would be Telegraph. You could use collectd. You could use even Prometheus. We decided that we're not going to ship yet another agent. So we just said, OK, if you like your open source agent, then use it, right? Send the data. Collect the data with your open source agent and send it over to Wavefront. As I've said before, you also have log files for converting log files to metrics. Because truth to be told, some products just don't have metrics emitting natively out of it, right? So we use Nginx ourselves a lot. And so for Nginx, to get metrics out of Nginx, it's going to logs, right? So we need to have some way that actually parse the logs and figure out, how many errors is happening, request size, response size, all that kind of stuff needs to happen, right? And as I said before, application code is also very important. So we look at a whole bunch of stats that are happening in the Wavefront platform. As you might imagine, it's things like, how many data points are being ingested, how many queries are being executed, how long are those queries being executed for. And so I would say most of our customers, 80 to 90% of the metrics that they send to Wavefront are custom. So it's related to their business. And there's a reason for that, because in a world that is ever changing in the cloud, where machines are being brought up, being torn down, you're running a serverless, you're using all sorts of Kubernetes service mesh and whatnot, which we are talking about later on. Things are coming up and going down all the time, right? The fact that you have a machine that is hot, running out of RAM, or running out of disk space may not matter at all if your customers are not having a degradation in their experience, right? So to the extent that you could collect metrics about your customer experience or their KPIs, that helps you decide whether to page people, right? So whether to alert people and to wake them up. And then you could look at the infrastructure metrics to see, is it because there's an infrastructure problem, right? So a lot of the times we monitor Wavefront with those KPIs. So if there is an ingestion drop, if people's queries are not responding, if they're getting a rejection in terms of rate limiters or maybe permission denials, all that kind of stuff, we want to know, because at a certain threshold, your customers are not going to be happy, right? So that drives how we monitor our system, how we alert on top of that data. And so I titled that flexibility because, as I said earlier, I think as we started the project, the company, it was really just a system for you to plop in data, right? It was just a proxy that we would ask customer to install, and it would expose a graphite port, right? That's kind of Wavefront Rev 1. And then very quickly, we realized people wanted to have CloudWatch metrics. People wanted to convert logs to Wavefront metrics. People want to be able to get their collectd metrics, their Prometheus metrics, get their Kubernetes metrics. And so that very quickly expanded into just a sink where we could gobble up all the data that you want, right? And so as we operated Wavefront, we realized we do not want to build the system so that it can only understand one kind of data, right? We need to be able to gather things that a lot of the times our customers send data to us that we have no idea what it is, right? For example, if you look at some of our customers like Lyft, they're sending us a lot of data about their rides, for example, and we just don't know what it is. It's just time series data. It has a timestamp. It has a value. It has a bunch of dimensions to it. We take the data. We crunch the data. We alert on the data, and that's what our customers expect us to do, right? So that flexibility trumped a lot of the decisions that we could have made, right? For example, a lot of APM solutions are very rigid in terms of how the data is collected, right? Some commercial monitoring systems are also very rigid in terms of what they can collect. But for us, as we looked at what the market wants, what we want was to have a system that, as long as it's time series data, as long as you could convert even some kind of unstructured data into structured time series data, we will take it and we'll ingest it and we'll just give you amazing looking charts out of them, right? Cool. So the next thing that I think we kind of learned is scale. And I think when we first started the company, we thought scale would be obviously important because you want to be able to take as much of that data as possible. But we don't really know how much is a lot of data, right? So you could kind of think like, okay, well, if a host generates 15 PPS, then maybe a large-scale data center generates, depending on how many machines you have, that's how much metrics you would gather. But as I said before, 80 to 90% of the metric actually comes from custom sources. So you don't really know where that, there's not a very easy way for you to quantify, did we build a platform that is enough? Right. The only way that oftentimes we talk to customers, they don't even know how much data points they're generating, right? Because they're probably using a whole bunch of tools. They're probably using a whole bunch of open source silos, and they don't have a clear understanding of just, okay, I know I'm sending in 700,000 PPS, right? I don't think if we ask a raise of hands from people here, you may be able to know how much data points your environment actually needs, right? So very early on, I think we settled on using a piece of technology called Foundation DB, which some of you guys may know. And it is an at-scale key value store, right? And so we switched from using HBase, using HBase, using MySQL, and using Zookeeper into a platform that is relatively unknown at that time called Foundation DB. It's now purchased by Apple. It's now an open source project out there. And but I think one of the early challenges that we thought was, okay, we know this has to scale, so let's make sure we pick a technology that we know could scale with us, right? And we talked to the Foundation DB team very early on. Most of them are still at Apple today. And we really felt like they knew what they were doing. The first thing that they did was they spent 5 years under wraps thinking of a language to express distributed data. Right, so that's in my mind, an enormous amount of time to just figure out how to actually run simulation of huge amounts of data coming into a system. And they were able to build a language that's on top of C++ that compiles into C++ ultimately, that allows them to build a at-scale key-value store. Right, so we decided to go with them, knowing not too much about how that technology ultimately is going to play out, but we chose them because we thought they had the right building blocks. They had the right mindset on how to build an at-scale key-value store. So we kind of ditched a lot of the data stores that we have, and we are proud to say we're currently fully on Foundation DB today. So scale is also a lot of factors, right? There's an ingestion factor, and there's also a query factor. So we certify our builds internally to take about 1 million data points per second before we certify our internal builds. So as you can imagine, that's a lot of data points coming in. To give you an idea, I believe the largest Aurora instance that you could run on AWS is 100,000 rows per second written, right? So if you're writing beyond that, then you have to look at something else, right? And Aurora is the highest performing database that they have on Amazon, right? So for us to run a transactional ACID database at millions of data points per second, we have internally benchmarked that to go beyond 4 million data points written per second, rows written per second. Yeah, that's a benchmark that we internally kept to make sure that we can scale with our customers, right? And as I said before, a lot of our customers are already at 1 million data points per second, so we're constantly trying to stretch how far we could go with what we have. I said before, there's also the query aspect, right? So if you could ingest 1 million data points per second, what we discovered is most of the data points that are ingested are not queried immediately. So meaning most of the data points that you use, you probably monitor your business with about 5 to 10% of those data points, right? So maybe a lot of those data points are used for firefighting, maybe it's used for cost analysis, maybe it's used for projections, or maybe just in a rainy day, right? So if there's an outage, you want to figure out what's going on, you want to make sure you have the data, right? Instead of having to maybe make a release or something like that before you could actually get to that data. So most of the data is not immediately accessed. But for that 5 to 10% of data, we actually get about 200 to 300 times more access on that data after it's ingested. So as you can imagine, that means when we have 1 million data points ingested, you have to be able to pull back tens of millions of data points per second out of your data store. Right? So that's an enormous amount of read that comes out of a very hot portion of the rows that are written. Right? So that's the scale. I would say the two primary scale levers that we have to work with is how quickly can we write the data into the system. And we did a whole bunch of work on scaling with Foundation DB as a company and nowadays as an open source project. And then also pooling the data out of the system so that you could run through all the analytical functions and all that, all the language primitives that customers are familiar with and give an answer to the user. So the second part is scaling process. And so I don't know how many of you use Terraform for doing your deployments. We didn't start with using Terraform, right? I think first of all, when you kind of start in Amazon, the first thing you do is you SSH, right? SSH the machine, and then you apt-get, right? And then install a whole bunch of things. After a while, you'd be like, well, this is not going to work because every time we have to add a new database, for example, you need to call up your ops guy and be like, 2 hours. Right? 2 hours, we'll get the machine spinning up, and then you then look at, okay, maybe you could use things like Chef or Ansible and things like that, but then you quickly realize the entire AWS infrastructure is huge, right? For us, we're spinning up VPCs, we're spinning up security groups, you're spinning up routing tables, you're spinning up, again, DB nodes, app nodes, ASGs, all that kind of stuff, right? And so you need to have some way to know that the system is exactly as you described, right? And so that's where infrastructure as code comes in, right? And so at some point in that journey, we decided, okay, this process is not going to scale because we can't just have people spinning up database nodes and taking 2 hours, right? And so we just need to have something that can just conform a cluster using the known declarative intents, and we chose to use Terraform. So that's kind of just one aspect of how we scaled our process. And then scaling people, I think that's also a tough job, especially as a startup, right? So we started in Palo Alto with 4 founders, and when at the point of acquisition, we have about 70 people, right? So, but it's a very tough piece because in the Valley, hiring people is hard, and hiring the right people perhaps is even harder. And so we had to make sure that there's enough mind share so that engineers can, if there's a problem, engineers can look at the issue. There's operations engineers that are on call all the time. And I'm sure we have a bunch of Wavefront engineers here as well. Like most engineers really dread being on call, right? So they're scaling people is also like how do you actually scale the process of getting people to become on call, to know the run books, to figure out so that it's not like a hot potato. So it's like, okay, this is my turn to be on call. If I could just last until Friday where it switches to the next person, and then I could just hand off the pager to the next guy, right? So that is a lot of, writing down run books, but also just convincing people like, hey, it's your duty to keep the system online. It's your duty to find the right people, right? Wake the right people up if you don't know how to fix the issue, and just surface problems before they become a customer-facing issue, right? And then finally, I think scaling the business. So this is mostly going to be a technical talk. So I think scaling the business is a lot about how do you do go-to-market, how do you do sales, how do you do marketing. But in terms of as a developer, as I look into it, for most of the ideas, I would say that came about in the first 2 years of us being Wavefront, a lot of it was just us, the founders, sitting in customer meetings and just listening to them, right? You go to a customer site, and you look at how they use Wavefront or how they use their existing tools, and you have and then you have some epiphany, like, oh, this is a problem. Like they're clicking too many times to get to an issue, or get to the resolution of an issue, and you very quickly figure out you could make the product, you could make that particular feature a part of your product. And so scaling the business or getting more leads or getting people, your existing customer, to be more engaged with your platform, a lot of the times is about just having engineers, having technical folks sitting down with customers and asking them questions, or just observing how they're using your platform. So one big piece that we learned is the analytics piece. So if you have used Wavefront before, we have something called the TS language. And so we kind of developed that language our own. And so I used to come from Google. And so Google internally has a monitoring language called Borgmon. And so that's the joke was that, sorry, some background. So in Google, before you can commit to any language of your choice, meaning you could write code and commit to Perforce back then. I think they're still Perforce. So that you need to have readability. So somebody with readability needs to review your first commit and tell you all the things that are wrong about your code, right? You're not using the right tabs, right? You're not using the right line breaks or stuff like that. And before you do that, then you could actually commit code to the repo. And so for the monitoring system, which is Borgmon, there's also a language. And the joke at Google was that Borgmon is such an unreadable language that they question why there is readability requirements for it, right? So because it just seems like an oxymoron. So we originally thought, building and at scale a SaaS monitoring platform would be cool, but we definitely want to make the language easy. We want to make sure that you don't need a multivariable algebra degree to understand how are you, multiplying these matrices together and to actually give you a two-dimensional plot of your data, right? So one of the things that we thought would be cool is to look at how we could use composition, how we could have as much intelligence as possible so that you could just craft a function and wrap them with increasing complexity and then to get to the answer that you want. So this particular query here is just basically saying, give me all the time series that are called web requests. They have to be in SFO. They have to be for the front-end service. And I want you to take a first derivative on it. And so that's the rate function. And then finally, I want you to do an aggregate on that with a group by that's on release. That's the dimension that I want you to do a group by on. So I think that's, I want to challenge anybody to show me a language that has more density in that than that, or meaning that you could express that kind of an intent in that number of characters. And I think that's important because when you're doing firefighting, you don't want to be figuring out SQL, right? You don't want to be figuring out how you could type the exact syntax. You want to be able to very quickly get to the data that you want, collapse it or aggregate it in the exact format that you want, and get to the answer. So in this particular case, you're probably looking at the number of web requests per release, right? Very, very useful information because if your new releases starts to have a problem and the request starts to plummet, that's a clear sign that you perhaps need to revert, right? So that is an example of a Wavefront query. And that's an important part of how our users experience our product too. Because a lot of the times the data that you're sending into Wavefront is not the data that you want to present on a chart. So a lot of systems, it's just a time series database, right? What you see is what you get, or what you ingest is what you get. So if you send us this time series, it's going to just come back as is, right? So if you want it to look correctly, you have to do the transform beforehand, right? So a lot of that happens in for example, like statsd. For example, because I need a counter, so I need something that sits in front of my time series database that are counting things so that I could actually get to the chart that I want, which is likely maybe a first derivative or a rate, right? In Wavefront, you could send the data to Wavefront as it is. Maybe it's a counter. Maybe it is an event-looking time series. And you could then apply those language primitives on top of that. And what that allows you to do is to basically slice and dice the data however you want, right? So that's an important thing that we implemented in the product, to have that language primitives. And we kept on adding more of it. A lot of those language primitives that we have today is just a lot of times our customers showing that, hey, like I'm doing this 20-line query to compute this moving Pearson correlation. Can you just not have moving Pearson correlation in Wavefront? And we said, yeah, sure. We could actually do it better because we could probably do optimizations underneath the hood. And so in the product today, we have moving Pearson correlation. A lot of the recent stuff that actually happens in the platform in terms of forecasting, automatic anomaly detection comes from that, right? It's a lot of statistics principle, but a lot of people tell us, like, I don't want to pull out a stats book to learn triple exponential smoothing. I just want your thing to tell me, give me a forecast, tell me whether it's anomalous or not based on these stat techniques. So a lot of that is implemented into the platform today, and we look forward to just adding more of that as we discover customers doing interesting things on our platform. So finally, I think I'm going to talk about real-timeness of the platform. And so as I said before, it's 70 trillion points ingested so far. We handle globally around 5,000 queries per second. We have more than 10K interactive users that are using the platform today. Some of our largest customers have about 4,000 to 5,000 active users. So as you could see, like, this is not a tool that only maybe a couple of operations people use. We have heard from customers where they began their cloud journey, and very quickly the finance person is very concerned because you're going to spend a lot of money, right? And so in the past, what companies have done is, let me just give you access to AWS, and you could just look at the data. And then you very quickly realize, well, then you have to do like 2FA. You have to figure out, like, because they have access to just probably too many things that you don't want them to be accessing, right? So our customers, what they did is, well, you could actually pull out all of the billing information from Wavefront into, from CloudWatch or AWS or GCP or Azure and plop them all into Wavefront. So the finance guy now can just look at a dashboard that's telling them about just finance, right? It's not even operational analytics technically. It's just data about their cloud spending, and they're sending all of that into Wavefront. So you could see, product managers using it to understand, is my feature being used? I just launched a feature. In the past, the product manager needs to grab a database analyst and be like, how many people use this feature, how many transactions, and stuff like that. And now they could go to Wavefront, as long as they've instrumented the code with some custom logic, they could go in and say, OK, I have a chart that is real time, right? Once the product is launched, I switch to the 10-minute view in Wavefront, and I could see in real time who is using that particular feature. Right, so it very quickly snowballs into developers using it, obviously operations folks using it, but product owners, finance teams, and all that kind of stuff. They're just collaborating on Wavefront and using that to discover insights about their business essentially. And as Mahesh said, I think our median query latency is about 30 milliseconds, and I think that's a very important benchmark for ourselves. We set the internal benchmark to be 100 milliseconds because that's how fast your eye blinks, and so that's how Google kind of sets their P99 for Google searches. All of the searches need to come back within 100 milliseconds. So for us, you could always incant a very difficult query, so we didn't say P99 would be 100 milliseconds, but we set the median, which is kind of the average experience of you using Wavefront should be the blink of an eye. And I think that's important because we are very used to Google being very fast. So when you type a query that's wrong, you don't feel penalized, right? You just go up and change the query and then search again and be like, oh, no, search again until you can refine the query so that you can get your answer, right? And with Wavefront, we want that to have that same experience so that when you're editing a query, I want to look at this. OK, that's not the right thing. And look at this, not the right thing. And I want to do a language transformation on it. I do that transformation and I see the data, right? So that kind of iterative process is important. So you don't feel like it's kind of like a database where it comes back with answers after 60 seconds. So I better craft the right query, or else I'm just going to run it and be like, oh, that's not what I want. I need to do it again, wait again, and they come to my answer. And all of that plays to how quickly you could resolve issues, right, in production, because you could get to the answer very quickly. And so that 30 millisecond time is a lot of optimizations, as you could imagine. We are a Java shop, right? So if GC kicks in, it's very easy for them to just get your query latencies way higher. So a lot of time was spent on testing different GC tuning parameters, picking the right garbage collection algorithms, and just monitoring. We have a histogram product inside Wavefront, so you could actually gather sub-second samples. So we could actually detect minute pauses within the JVM and report that as a high-definition histogram into the platform. And when we notice that distribution changes, we could actually figure out, is it because somebody issued a query that is causing a whole bunch of GZ pauses, or is that a release that we just did that actually is causing that? So a lot of care and feeding has gone into making sure that the system stays real time, the system feels like it is snappy. And oftentimes I go to customers, I show them Wavefront, and the first thing that a lot of them ask is this running on your browser? Like, is the data locally on the browser, and you're like tricking me with how it works, right? So I think that's a testament to a lot of the work that's been done. Even just operations team figuring out how to use HTTP2, right? How to tune the browser so that the data can get very quickly to your browser. How to gzip the data properly so that even when when the cluster is on the West Coast and you're in Europe, even then, the experience could still be fast. I think a lot of work was done making sure that happens. And finally, I'll end with reliability, because I think that's a very important piece. And I think oftentimes I hear some folks tell me, like, okay, it's a monitoring product, right? So it's not your business, right? So if it goes down, then okay, it's like not really that important, right? But I think our customers really hold us to that reliability number. It used to be that we have maybe 3 nines in our contract. I don't know even a lot of commercial offerings out there having the numbers defined in their contract. But our customers actually wanted 4 nines, wanted more nines, right? And because they really depend on Wavefront to do their job, right? Their NOCs are looking at Wavefront. Their entire company depends on Wavefront being up so that they could know what is going on with their business or their application or their service, right? And so a lot of the times when we have a problem, just even a slight glitch, even if queries start to slow down, we have had customers tell us, like, we go into company freeze, like company-wide code freeze, because we just don't want to do any change to the platform if we don't have perfect visibility, right? And so I think from what we've learned in building Wavefront, it is not just a piece of monitoring software, so it could go down, come up, and stay dead for like 20 minutes and come back, or even be slow, right? So a lot of the work to ensure that the system is up was spent very early on, I think, and a lot of blood, sweat, and tears was shed, because we had an HA story, we had to augment that HA story, we need to fix bugs in our code, we have to fix bugs or work around bugs inside the JVM, work about bugs with AWS, or even just convincing them that there's a bug in AWS. And so a lot of that is to focus on keeping the platform up, and not in the sense that it gives you a login page kind of up, but like it is responding to queries as quickly as a 30 millisecond kind of a target, as well as ingesting data point at 100% of capacity, right? So that's a lot of work that we've done. And so this is a quote that I like from Amazon AWS's CTO, Werner Vogels, and he said, "I've hugged a lot of servers in my life, and believe me, they do not hug you back, they hate you," right? So if you've operated anything at scale, you probably understood like kind of just the law of probability. Even if you have just a failure rate or mean time to failure, of years, if you run enough of those instances, drives, machines, switches, network cables even, they will fail, right? And they will fail in frequency that will be alarming to you, right? So a lot of the time was spent to make sure that every single piece of architecture has a way to fail over. It could be in code, right? Meaning if we can't make a database call, how can we make a call to another replica to make sure that we could answer the call? If we're ingesting data, if we cannot directly write to disk, can we write to a queue? If we cannot talk to the service that can write to the queue, can we directly talk to the queue? If we can't even take that call, can we push it back to the customer site and have it write to disk on the customer side, right? So a lot of that is engineered into the product so that whatever happens, in the unfortunate case where it's a machine failure, a service failure, meaning a AWS component failure, or a network failure, or a connectivity failure, or a bug in the code, we could always have a way to recover from that. And I don't know if anybody remember this, but I remember this like it was yesterday. In 2014, September, Amazon rebooted all of their machines in one day. And they would tell you about 20 minutes in advance which machine is going to reboot. And they didn't reboot all of the machines, so thankfully, right? So we were already operating at scale at that time. And when we heard about that, I remember there was a 24-hour time when everybody was up. And it was really groggy. I remember that we were all very groggy at the end of it. But we had to make sure that when Amazon says it's going to nuke that machine, that we're monitoring the system so that all the things that I described, right, all the redundancy measures are kicking in correctly, and that when it comes back, replicas get out of sync, right? So you have to make sure that they come back, they figure out like, okay, I was out for like 20 minutes, and I come back, and so what has changed, synchronizing all the state across the fleet. And thankfully, our customers didn't see a problem in 2014 as part of that journey. But I remember that was a harrowing tale, and just as a stressor for making sure that our platform can survive just any kind of outage. Yeah.
So do you run regular chaos exercises now to protect yourself from that sort of?
Yeah. So the question was whether we run Chaos Monkey, I guess, kind of exercise in production. So we currently do not run Chaos Monkey directly in production because of our customers' requirement that is 4 nines of uptime. But we do have many clusters that finance pings me on why we're running. But we do a lot of things of yanking things out, running on spot ins. There are ways to do fault injection, and so we try our very best to do that. And before we make releases of data of basically FDB, we basically ask our ops guys, like, please break it. Like, show me how you could. I mean, there are obviously ways to break it. If you shut down the entire database, all the nodes, I mean, the system will not answer to any requests. But do that and turn it back up and see how quickly it recovers, right? All that kind of exercise are there. And I think for a stateless system like most of our microservices, that's easier to manage. But the data layer is really the hard part. Like, you want to make sure that, in a distributed transactional key value store, whatever is committed is actually the ground truth, right? So there's a lot of work there to make sure that happens. Yeah. So we do that as much as we can.
How do you handle regionalities?
Regionalities. Yeah. So we do have a DR solution, and I hope some of our Wavefront guys are here. So we actually moved one of our largest customer across the continent over the weekend. So we started off running basically HA replicas of Wavefront in the same region. So if you're in US West 2, like Oregon, you would have 2 copies of Wavefront that share nothing. So even internal ID assignments and stuff like that are separate, so we don't have to lock transactions or stuff like that across the AZs. So it's application level replication, if you will. And so at some point, our customer said, okay, we really need DR, because when Oregon falls in, if Oregon falls into the ocean, we want to make sure that you have some East Coast replica that's available. And so we kind of took what we have with HA, and we said, okay, if we move a mirror to another region, then you basically have that region level isolation. Yeah. So we do have that region level isolation. A lot of it is making sure your network fabric can stick together. So you actually have addressable routes, you have VPNs, you have multiple points of VPN, so you could tolerate a connection failure and whatnot. Yeah.
Would that be seamless as data is being published?
Correct. Yeah. Yeah. So internally we have queues that are doing these kind of application level replication. Yeah. So again, we don't use a database level replication, because with that then you basically cannot serve hot. So within seconds we could switch replicas, and with DNS routing changes we could send traffic to another region. And because they share nothing, so effectively you could serve in both sides, but it's a capacity issue at that point, because you don't want both clusters to be running, redlining them, and then suddenly one of them goes out, and then you really have a problem because your remaining side cannot actually take double the traffic. Yeah. Cool. Yeah, and then last but not least, I think the platform is alive. I think as an entrepreneur building Wavefront and iterating a product, I think operations a lot of the times want us to not change things, right? Like, it's working, like, don't change it. Right? Why are you introducing new features? Why are there more writes? Why are there less writes? Or why are there more reads? And why are you upgrading the kernel, changing the JVM, right? And at some point, when I'm tired at the end of the day, I also ask that question myself, like, why are we changing the JVM, right? Why does Oracle wants to change the licensing model right, for JVMs and whatnot? Not sure they should be recorded. I know George quite well, so it's okay. So, but things happen, right? You have to iterate, right? Ubuntu will stop supporting security updates for older version of their operating system. The kernel, Amazon is going to tell you, okay, we don't like you running an older kernel against our EBS because it's not going to be performant. And so all changes are happening all the time to your code, to your platform. And so there's always going to be some degradation to your system. I think there's never that perfect, happy place where it's all good, right? At the least, your customer is going to issue a new query, right? At least your customer is going to come in and then issue a 20-page long query and then tries to take down your system. Or they ask you, like, why can't I do a 3-year-long moving average or stuff like that? And, well, it's just like 1 trillion points to pull out, right, from your data structure and then just collapse all of that into a moving window, right? There's always going to be the case where your customers want the system to do more. And so it is alive, and every release we look at, okay, there are optimizations that we could do, there are hotspots that we could look at, and how do we optimize that? And when a customer comes in and say, okay, the query is slow, how can we try to help them so that they could do better, right? So last slide is So what we picked up along the way is just some of the learnings. The first thing is to evolve everything, meaning to question all the choices of technologies that you've used, and to decide, whether you should pick something new, right? Switching from ourselves, switching from a kind of more manual deployment approach to Terraform, maybe switching from, actually sometimes it's not even your choice, we switch from Bamboo to Jenkins because Bamboo is being sunsetted by Atlassian, right? So all that kind of stuff that just happens because it's just always changing. So everything will be evolving, expect it will be evolving, and try to live with that state of degradation, constantly managing that degradation and making sure that you're serving your customers well because you're monitoring your KPIs, right? We use Slack a lot, so we encourage spontaneity. A lot of times, it's making decisions on the spot, right? You have degradations, you have issues, you have a mirror that's having problems, it's EBS, it's hardware, it's software, and people just trying things, right? Encourage people to try things, encourage people to make patch releases, to have a way for them to observe whether that's actually helping the situation, and just encourage them to break things and try to find solutions to those issues. Value retrospectives. So I think as a team that moves pretty fast, I think we still struggle with that, which is that last night somebody did some fix, right? It worked, and then the next day a whole bunch of people come in and they didn't know what happened, right? They have to go dig GitHub because at least some of the infrastructure as code piece means it's checked in. But you need to have people talk about what they did that worked and that didn't work, and so that they could actually share the learning, right? And I think we have some mechanism for doing that. Is a lot of kind of purposefully engineered meetings, if you will, that get people together and talk about it. It's writing up run books, it's writing up retrospectives, and one of the things that a lot of people tell me is I like to write really long emails, usually after an incident or after like a new feature that I thought was really cool. And I think writing it down helps you to crystallize what just happened, what the change meant, and what are the blind spot that could have been introduced by the change. And just encourage people to write it out and get it out there so that it's in someone's inbox, and then hopefully people read it and absorb that information, because you just can't scale where you have 100 engineers and all of them. You can't just have all of them looking at production all the time, right? Own your craft. I think encourage people to write the best code that they can write. I think a lot of times, engineers tend to have this mentality that if does it hit the requirement, right? The Jira ticket says it needs to do ABC. It does ABC, so it's resolved. So let's push it to production, right? But oftentimes, you really want to understand, why is there such a requirement, right? We use Wavefront every day to manage our own system. So if the requirements comes in and it doesn't make sense to you, it may not make sense to the customer as well, right? So you want to make sure that if you're just iterating a product or implementing a feature, you want to make sure that you could put your name behind it, right? I kind of like how cars do, right? At least for maybe some of the more expensive cars, the engineer would sign their name on the engine, right? Just so that the recipient or the buyer of the car knows that's that I have pride in what I just did. And I think that helps, I think, for engineers to know, people, you're not just some unknown person behind the scene that's writing code. People are touching that code, and I want them to feel like if they go to a customer, they could say, I wrote that feature, and hopefully the customer likes that feature, and they could feel proud about them owning that feature, right? And finally, I think for a lot of engineers, I think it's easy for us to just be in our own sphere, right? And I come to work, I write code, commit it, do a bunch of Slack stuff, and then I go out. But I think there are obviously things like meetups that are happening in the Valley. There are things like a lot of customer events, right? A lot of conferences that you could go to. Oracle Code, I think they renamed Open World to Oracle Code, happens this week, and they talk about a whole bunch of things about Java, right? We happen to be using Java, and so encourage people to go. Encourage people to go and get inspired by what other people are doing, and encourage them to go visit customers. Encourage them to just get out of where they are. And so I think that's some of the key learnings that we picked up along the way.
Clement,
Yep.
could you unpack your decision on queuing? Did you roll your own, or did you take something off the shelf?
We actually use SQS from Amazon, yeah. So I think we decided that we do not need at most once delivery. We do not need ordered delivery. And so we just thought, okay, well, we're on AWS at that point. Let's just kind of use their SQS. With simple queuing service, which has no deliver once guarantees. There's no transactional guarantees. There are no, there is also a very significant size limit on the message as well. But we were able to work around all of that. And so far, for the last 4 years, that has served us well. Like we didn't have to stand up, let's say, Kafka or ActiveMQ or RabbitMQ or all that kind of stuff. Yeah. So I don't have any more slides, so it's open to questions from anybody from the audience.
Thanks a lot, Clement. Any other questions? Any last questions for Clement?
Definitely want to encourage everyone to give Wavefront a try. So it's wavefront.com, and even if you're using, we basically have SDKs for all different languages like Go, Python, Java. I said we are Java shop, but we obviously have a whole bunch of SDKs that are for different languages. So if you're writing anything, at some point last year when I was coming back from Barcelona, I was like, it would be cool if I happen to drive a Tesla. It would be cool if we would get metrics from the Tesla in Wavefront, right? Just like how we talk to cloud providers, right? So I remember like on the flight back, like I just whipped up my laptop in the flight, and I was like, okay, this is how you could get metrics from the car, and you could actually get metrics from your car. Right? I understand a lot of cars today are connected, so you could actually very easily write a Python script that scrapes the metrics and plop it into Wavefront, and you'll be amazed as to how much insight you could get, like just by understanding when your trunk is open, maybe accidentally sometimes. Yeah. Cool. All right, thanks everyone.
All right.